Welcome to Keys Consumer Math and Personal Finance, Section 1.6, Solving Equations. We are simply going to do several examples of solving equations. Before we begin, though, you should study the examples in Section 1.6 of your book, and then come on back to the video. In these problems, it simply says to solve. So that's all we're going to do is we're going to solve for the variable. I think in all the cases it's an x. And we're just going to walk step by step how you do them. I'm going to show every step to start with, and then I'm going to start skipping, showing all the steps, because you're probably in a place where you can do that. So we're going to isolate the variable, but on problem number 1, there's variables on both sides of the equation. So what we need to do is move all the variable terms to one side of the equation, and all the terms that have no variables, all the constants, to the other. So I'm going to do that by taking this 2x and moving it from the right to the left. So the way that I do that is that's 2x minus 2, but you're adding the 2x there. So I'm going to do the same thing to both sides so it stays balanced. And then I'm going to, at the same time, I'm going to add or subtract actually 7 from both sides because I'm moving the constant. Because whatever I do to one side, I'm going to do to the other. Keep it balanced. And now I'm going to add them straight down. 5x's minus 2x's gives me 3x. 7 minus 7 cancels out. 2x minus 2x cancels out. And negative 2 plus negative 7 is negative 9. Now I'm going to come up here to the next step. So this is a multi-step problem. 3x equals negative 9. I want to isolate the x. It's 3 times x, so to undo multiplication, I divide, and I'm left with x equals negative 3 because I do the same thing on both sides. Alright, number 2, there's a variable only on one side, but it's negative, so we'll have to deal with that when we get to it. First, I'm going to isolate it by subtracting 4 from both sides to keep it balanced, and that cancels out, and I'm left with negative x equals 13 minus 4 is 9. So I don't want a negative x, I want to know what positive x is. So what I'm going to do is divide both sides by negative 1. I'm not going to show that. I don't need to. X equals negative 9. If negative x equals positive 9, then positive x equals negative 9. Okay, on the next problem, I have variables on both sides of the equation. So I'm going to subtract, I think I want to go from right to left, so I'm going to subtract x from both sides to keep it even, and then I'm going to subtract 3 from both sides to keep that even because I'm moving my constants to one side and my variables to the other. 7x minus x is 6x, 3 minus 3 is nothing, x minus x is nothing, and 5 minus 3 is 2. Now in this case, I'm going to rewrite this up here. 6x equals 2. I need to get x by itself. It's 6 times x. So I undo it by dividing. Do both sides. And I get x equals 2 over 6. Well, 2 over 6 is not a reduced fraction, so I'm going to reduce it. And 2 goes into both 2 goes into both 2 and 6. So it's a factor of both of those. 2 divided by 6 is 1/3. Okay, on the next problem, I'm going to have to do something a little differently. I'm going to have to distribute. I can't solve what's inside the parentheses yet because there's a variable, and they're not like terms, so I can't simplify them. So I'm going to have to multiply let's see if I can make that a little clearer. I'm going to have to multiply everything inside this parentheses by 2. So 2 times 3x gives me 6x. And 2 times negative 5 gives me negative 10 equals 44. Now that I've done that, I can add 10 to both sides. Oops, 10 upward. And I get, over here, I get 6x equals 54. I want to isolate the x, so I'm going to divide both sides by 6 because 6 dividing undoes multiplication. And left with x equals 9. See, we're moving quickly through these, but they're not too difficult if you take them step by step. Now, the next thing I'm going to do is the next problem, which also includes distributing a number, but I'm going to distribute the negative. So negative 7 times x equals negative 7x. And then also distribute it to the other part of the parentheses. Negative 7 times 5 is negative 35. I could write plus a negative 35, or I could just write minus 35. It's the same thing. And then minus 9 equals 4x. Now I do have variables on both sides, but I needed to take care of that, distribute through the parentheses first. So now I want to, I've already got two constants on the left side, so instead of moving the 4x from the right to the left and moving the constants over, I'm just going to add 7x to both sides. I do the opposite of what it is. It's subtracted, so I'm going to add it. And when I do that, I'm going to write the answers up here. Negative 35 minus 9 is negative 44. Right? And then I'm going to add 4x plus 7x, and when I get that, I get 11x. So now I'm going to divide both sides by 11, because I want to get rid of that 11. And when I do that, I'm going to use my commutative property to switch the x, or actually this is the transitive, no, it's a commutative property. I'm going to switch the x and the 11 around, and I get negative 44 divided by 11 is negative 4, because remember, a negative divided by a positive, or negative, equals negative. Alright? Now let's do the next one. I'm going to distribute, I'm not distributing a 2 to everything in the parentheses on number 6. I'm distributing a negative 2. So this is x, and then negative 2 times x is negative 2x. Negative 2 times 3 is negative 6 equals 28. And then I'm going to simplify that by collecting like terms. Negative 2x plus x equals negative x. Minus 6 equals 28. I'm going to add 6 to both sides. And I get, up here, negative x equals 34. Therefore, positive x equals negative 34. Now I want you to see that not everything we work with in this class is going to be an integer. In fact, most numbers are not. Most numbers we work with in this class are going to be rational numbers. So let's practice some problems with rational numbers. First, I'm going to distribute the 3 to the 4.2 and then to the negative 3x. So I get 3 times 4.2, which gives me 12.6 minus 9x, because 3 times negative 3x is 9x. I can drop my parentheses because I distributed the 3, plus 34 equals x minus 7.3. Now I'm going to collect like terms on this side, and I get negative 9x. 12.6 plus 34 is equal to 46.6. Positive 46.6 equals x minus 7.3. Now, I'm not going to show all my work, but I'm going to subtract x from both sides. And when I do that, I end up getting negative 10x on the left side. And I'm going to add or subtract 46.6 from both sides. And when I do that, I'm going to add negative 46.6 to negative 7.3. And I get a negative 53.9. And then I'm going to divide both sides by negative 10. And when I do that, it becomes positive. And that when I divide, I just move my decimal one place to the left because I have 1 0. And I get positive 5.39 as my answer. And you can check all of these by taking this x and substituting it in to every x value you see in number 7, and then same thing for all the other ones. And if it comes out to be equal on both sides, then you've done it right. I'm not going to take the time to do that now. Now in this problem, we need to work with some more rational numbers, but this time it's fractions. So I'm going to isolate the negative 2/3 x on this side by subtracting 1 from both sides. I'm going to subtract 1 here. Now I'm going to subtract 1 from 4/9 also, but I'm not going to write it in the form of 1. I'm going to write it with a denominator of 9. So I'm going to write it in the form of 9/9 because 9/9 is equivalent to 1. And that way I can subtract it from that fraction. So I'm left with negative 2/3 x on the left side, and I'm left with negative 5/9 on the right side. Now, I want to get rid of this negative 2/3 x. And the way you do that is you divide. This is negative 2/3 times x. So you're going to divide both sides by negative 2/3. But when you're dividing fractions, it's the same thing as multiplying by its reciprocal. So I'm going to multiply by 3/2. Remember, when you multiply a number times its inverse, or its multiplicative inverse, then you're going to get 1. So because these 3's cancel, these 2's cancel, the negatives cancel, and I'm left with just 1x. But whatever I do to one side, I have to do to the other. So I'm going to also multiply this by 3/2. Now, I can cross cancel. 3 goes into itself once, and it goes into 9 3 times. I can't cancel anything else, but when I do that, I simplify it before I actually multiply it out. So negative 5 times 1 on the numerator is negative 5, and then 3 times 2 on the denominator is 6. So x equals negative 5/6 is the answer to this problem. This last example, before we move on to formula/word problems, I had accidentally erased, so I rewrote it, and we can practice it here. We are going to solve this by first collecting like terms on each side. So on the left side, we've got a 2x that's like a negative 8x. So when I collect them, 2x plus negative 8x gives me negative 6x. And then I've also got a positive 5 and a negative 9 as my constants. When I combine those, I end up getting a negative 4 out of that. And then on the right side, I can collect my variables, negative 14x and negative 3x. They have the same sign, so I add them, and I keep that sign. And then my constants, 18 plus 6. When I add those together, I end up getting 24. So let me write plus 24. Okay, now we have to put the variables on one side and the constants on the other. So what I'm going to do is I'm just going to add 17x to both sides, and when I add positive 17x to negative 6, I'm going to end up getting an 11x, and then I'm going to add 4 to both sides. Plus 4, 24 is 28. Now I'm going to divide both sides by 11, and I get x equals 28 over 11. That is not reducible. You can leave it as an improper fraction unless you're told otherwise. Problem 10 says, how long should Bid make his garden if he wants it to be 8 feet wide and have an area of 152 square feet? So we know it's 8 feet wide. We know the area inside is 152 feet squared. What we want to know is what is our length. So we have to use the area formula. An area of a rectangle equals length times width. Now we know the area, so we're going to write that down, 152. We do not know the length, but we do know the width, which is 8. And we're going to solve for L. So we just divide both sides by 8, and we end up getting L equals 19 feet long. And you always need to label your units every single time. The last problem we're going to do involves rate. It says, how long does it take to drive a car 246 miles at the speed of 65 miles per hour? So this is a rate problem. Distance equals rate times time. We know the distance is 246, so we fill that in, equals, we know the rate is 65 miles an hour. What we don't know is the time. So we just need to figure out what t is. The way we do that is we multiply, or we divide both sides by 65. And when we do that, we end up getting t, or time, equals 3.78. And because we were doing it miles per hour, it's going to be hours.